11, welcome to the last lesson of chapter 10, exercise 10G, multiple zeros. I don't know if you've noticed, but I actually skipped a few exercises because it was like an enrichment exercise or it wasn't very necessary. So this will be the last exercise of the chapter, and it's actually pretty easy because it's meant to be sort of a revision of what you've seen in exercise 10B, which is graphs of polynomial functions. We're just going to talk about multiplicity of zeros. So we've talked about multiple zeros or repeated zeros in that exercise before. Oops. But we're just going to refresh our minds. So, multiplicity of zeros. If we have a 0 at x equals to a, that 0 is known to have multiplicity of m if it can be factorized as a bracket raised to the power m. So I don't know if I've mentioned the word multiplicity, but we've definitely looked at multiple zeros. So this one, we are just going to learn a new vocab, multiplicity, which pretty much means the power on the bracket when it's factorized. Now, if that multiplicity m is even, we talked about how the graph is meant to bounce off at that value. So it's going to be a 0 anyways. So we already know it's going to be an x-intercept at a. If it's even, it's going to bounce off like this from the top or from the bottom like this. And if it's an odd multiplicity, then it's going to curve through. So we might have a over here, and it could bounce off from positive to negative direction or from negative to positive direction. And knowing the multiplicity, therefore, will help you sketch the polynomial. Now, some new vocabulary on top of that. If a 0 has multiplicity 1, which means it just cuts through, we'll call that a single root. And if it has multiplicity 2, we call that a double root. And if it's 0 with multiplicity 3, we call it a triple root. And anything above, we just call it 0 with multiplicity n, whatever n is. Now, a few more dot points. If xa is equal to x equals to a is a single root, then we just know it's a 0, hence the x-intercept. If it's a double root, which means p of a was equal to 0 and p dash of a was also equal to 0, that actually suggests, going back to chapter 4, it suggests that it's a stationary point, right? Because p dash of a is also equal to 0. And in this case, we say it bounces off, so it's more like a turning point rather than just a stationary point. Now, if it's a triple root, it will be three things. Its p of a will be 0, its p dash of a will also be 0, and p dash dash of a is also equal to 0. So this one actually suggests that it's a stationary point, but it is specifically a horizontal point of inflection. That's why it curves through. I hope that makes sense. So noting that will also help you identify what the values of the derivatives or the second derivatives should be. Let's have a quick example question and finish the chapter. So if you're asked to sketch a function like this, easy. We just have to identify a few things. So the first thing you want to have a look at is the degree. We've got a cubic, quadratic, and a linear. So if you multiply those terms together, you add the indices together. 3 plus 2 plus 1. The degree of the polynomial is 6. Now the leading coefficient is also important in sketching. So if you find the leading coefficient, it's going to be 1x times 1x squared times 1x. It's just positive 1, isn't it? Now, x-intercept, of course, will be 0, -2, and +2. Let's just identify what type of zeros there are as well. So at x equals to 2, this one doesn't have any power on the bracket, so this one's going to cut through. It's a single root. At x equals to -2, it has multiplicity of 3. So I can see that it's a horizontal POI. And this one, where x equals to 0 came from, its multiplicity is equal to 2. So that's going to bounce off. Noting that just helps you to sketch. So let's see. X-intercepts at -2, 0, and +2. Now, knowing that the degree is even, I also know that the endpoints have to face the same direction. And knowing that leading coefficient is positive, I know the endpoints should be both pointing upwards. So let's start there. At -2, we should curve. Oh, that looks ugly. We should curve because it's a horizontal point of inflection. At 0, we should bounce. So I actually can't cut through like that. I'll need to bounce back down. And at x equals to 2, I need to cut through without curving. So it looks a bit weird, but I probably need to make it more dramatic to make it easier for you to see. It's going to be more like that. It needs to clearly curve through at -2 and cut through at x equals to 2. Y, x. Hopefully that's not too difficult if your understanding of exercise 10b was okay. And if you do lots of practice, graphing polynomials should be easy peasy. And I think that was it. For this exercise, you are going back to Cambridge textbook, you're doing these questions. And that's the end of the chapter. So well done if you have actually watched all the videos and went through the examples together. Now is the time to catch up on the work, and if there's any questions, you can send me an email about it. Well, good luck with the homework. I will see you guys face to face in term 2. Bye!